Hello everyone. Today we will start Atomic Physics, IGCSE Physics. After the end of this class, we will do a topical past paper related to this atomic physics. So let's start our lecture. So first of all, the word atom. The word atom means atom is the smallest particle of matter. Basically, if we discuss the structure of atom consists of a heavy part which is nucleus, and there are some orbits around the nucleus. So this is structure of atom. Atom consists of three basic particles, uh, the proton, electron, and neutron. The proton is in nucleus and neutron, and electron, which is third fundamental particle which revolve around the nucleus in specific orbits. So there are three fundamental particles. So let's start from nucleus. What is nucleus? It consists of neutron and proton. Basically, if we talk about these particles, which are neutron, electron, and proton. If we talk about neutron, basically neutron have no charge. It have a mass, but neutron have no charge. While other particles, just like proton or electron, have charges. So proton have positively charged, while electron is a negatively charged particle. Let's talk about some properties of atom. Uh, First of all, what is atomic number, or you can say charge number? Atomic number and charge number are denoted by Z. So it is defined as the number of proton in an atom. The atomic number only consists of number of proton in an atom. So what about neutron and proton? Basically, the combination of neutron and proton is called atomic mass. And atomic mass is denoted by A. And it consists of two particles, number of proton and number of neutron. So it is also called nucleons because these two particles are in the nucleus. So we can also write it nucleon number or nucleons. We can also call them nucleon number or atomic mass. So What about the symbol of an atom? In general, we can write the symbol of atom. So this is a symbol of an atom, and here is a mass number. Here is the place of atomic number. So by using this formula, we can find the neutron number. So A is equal to Z, which is proton number, plus N, which is neutron number. By making the subject N, we can find A minus Z. A is atomic mass number while the Z is a proton number. Let's suppose it is a uranium 235. Uranium 235 have atomic mass 235 and its atomic number is 92. What are the number of neutron in this atom? Basically, according to this formula, N we have to find. And what is A? Atomic mass is 235 minus the proton number are 92. So this is 143. So number of protons are 143. So how can we find the number of proton by using this formula? Next, we will discuss about isotopes. What are isotopes? Basically, isotopes can be defined in which the particles, the atoms of same element that have different numbers of neutron and same number of proton. The isotopes are the atom that have same proton number and different neutron numbers. So these are isotopes. Let's take an example of hydrogen. Hydrogen have total three isotopes. Uh, one isotope that have only one proton and one electron, because in any atom the number of proton electrons are same. That's why atom is a neutral particle. This is called protium. And another example, which is second isotopes which have number of proton is one, which is we can write, we have write that the isotopes have same proton number but different neutron number. So proton number remains same and neutron is one and electron also equal to number of proton. So this is called deuterium. And third example is here in the nucleus, number of proton are is same but neutron number are different. Here is two. So it have one electron. So this is called tritium. So we can write symbolically the hydrogen atom. In this case, the proton which have only mass number is one and proton number also one. And in this case, mass number is total two. Number of nucleons are two, but proton number is one. In Similarly, in third case, the number of nucleons are 1, 2, and 3. So here's the example of isotopes. Another topic which is radioactivity. There are many particles discovered in periodic table, but that particles which have they emit radiations. This is called radioactivity. The radiations have three types: alpha radiations, beta radiations, and gamma radiations. So let's talk about the properties of these radiations because these are very important. And we will do the past paper question, which is latest 2023 paper related to these properties. So let's start the properties of these radiations, alpha, beta, and gamma. So first of all, I would like to write alpha, and the symbol of alpha is just like this. This is beta, and the symbol of beta is this, and last one is gamma, and the symbol of gamma is like this. So first of all, we will talk about the nature of these radiations. Basically, nature is alpha. The nature of alpha is helium. Basically, these are helium particles which have four atomic mass and two atomic number. And the beta particles are the electrons. And electrons have -1 charge while they have zero mass. And the gamma particles are the electromagnetic radiations. These have neither mass nor atomic number. So these are electromagnetic radiations. Okay. There is another property which is speed. The speed of alpha particles is very low because it have greater mass. So this is the speed of alpha particle is 0.1 times the speed of light, which is very slow as compared to beta and gamma. While beta particles have 0.9 times speed of light because they have no mass. But in case of gamma, gamma particles are the electromagnetic radiations, so they have the speed of light. Okay, next another property which is ionizing effect. What is the ionizing effect of alpha, beta, and gamma? The ionizing effect of alpha is strong because alpha have greater mass as compared to beta and gamma, while the ionizing effect of beta is weak and gamma also have zero mass. So the ionizing effect is weak of gamma particle. That particle which have large mass having the stronger ionizing effect. But what is the case of penetration power, penetrating power? The penetrating power of high, the penetrating power is high of that particle which have zero mass. So alpha particle have greater mass. So penetrating power not very penetrating. These particles are not very penetrating because they have greater mass. But these are very penetrating beta particles because penetrating. And what in the case of gamma particles, they have speed of light. They have larger speed, so their penetrating power is very high, which is we can write very penetrating. Okay, let's talk about last property of alpha, beta, and gamma radiation. Which one is effect from fields, electric field and magnetic field. So when these particles pass through these fields, what is the effect of the field on these particles? So alpha particles have positive charge, so they deflect it, while beta particles have negative charge and zero mass, so they are greatly deflected. And last one, gamma particles have zero mass, so no charge basically. So they are not deflected, they move straight in these fields. So these are the properties of alpha, beta, and gamma. So let's go for past paper, latest past paper 2023. We will do the topical question related to this topic. This is May June 2023, variant 2. The question number is 9 related to atomic physics. So here is question number 9. Table 9.1 show more some properties and values of alpha, beta particles and radiations. So complete this table. So we have discussed these properties about alpha, beta, and gamma particles. So in alpha particle, the number of protons are 2. What is the number of neutrons? We know that the mass number of protons is 4. The mass number of alpha particles is 4. So here is a 2 proton. So there must be 2 neutron. And what about the beta particles? In beta particle, the number of protons. We know that the mass number of proton is 0. So there is no proton in beta particles. And what is the charge? We know that the beta particles are electrons. So charge on beta particle is -1. What about gamma particles? Gamma particles having number of proton is 0, and we know that gamma particles are neutral particles that have no charge. So it can be 0. Number of neutrons, sorry, the number of neutrons also 0 because mass number is 0 and it have no charge. This is a B part. State how beta changes the nucleus of an atom. So when the beta decay from some element or atom, uh, there is one less neutron, and proton is increased by 1. So one more proton. So you will get the 1 mark. Here is another part C. A radiation detector used in laboratory detect the background count rate of 30 count per minute. Means 30 counts in 1 minute. A radioactive source is placed in front of radiation detector. Radiation detector is detect the number of radiations per minute. The initial reading on the detector is 550 counts per minute. The half life of the source is 25 minutes. Calculate the expected reading after 75 minutes. Means there are three half lives: 25, 25, and 25. It would be 75 minutes. So after three half life, what would be the count rate uh, after 550 counts per minute? So there should be three steps. The number one step number one is identify and remove the count rate to found the initial count rate due to source. Done. So first of all, step one will identify and remove count rate to find initial count rate due to source. Done. So we know that the background count rate is 30 count per minute and total count rate is 550 counts per minute. So initial count rate would be find 550 minus 30, which will be equal to 520 count rate per minute. This would be the initial count rate of the element. So let's start to find the count rate after three half lives, means to after 75 minutes. So step two is Calculate how many half-life has passed. Half-life has passed. So verbally we know that there are three half-life that will be passed, but we can also find by using, we know that 75 total minutes, and there is 25 per minute, which is equal to three half-lives. So in next step, we will find the count rate after three half-lives. So this would be the last step. So number three is, uh, you know that when count rate was 520 after first half-life, the count rate will half. So it would be 520 by 2, which is equal to 260. And after second half-life, there would be more half. So it will be 130 count rate per minute. And after third, which we required, there would be more half, which will equal to 130 divided by 5 divided by 2, which will be equal to 65 count rate per minute. So right answer is 65 count rate per minute. Okay, let's go for the last part of this question. This question contained total 10 marks. So state option D is state two safety precautions taken when moving using strong radioactive source in a laboratory. We know that these radiations are very dangerous for skin. So uh, first of all, store the source in lead box because it contains heavy gamma particles, and gamma particles are stopped by a lead sheet. So store the source in the lead box. Stay away from the source.